Okay, here I am presenting Unit 4 syllabus. Unit 4 syllabus, that is inter-process communication. In that, introduction to IPC, IPC between process on single computer system, IPC between process on different systems. That is the integration process communication. Next topic is pipes. That is creation of pipes, IPC between related process using unnamed pipes. Okay, that is the pipes. Next topic is FIFOs. In that FIFO creation, okay, IPC between unrelated process using FIFOs, named pipes, difference between unnamed and named pipes, P open and P closed library functions. This is the FIFOs. Next one, message queues. Kernel supports for messages and APIs for message queues. Next topic is client server example. Next one is a semaphore. In that kernel supporting for semaphores and APIs for semaphores while locking with semaphores. This generally these are the topics we will cover in fourth unit. Okay, first topic is uh, okay. That is you can discuss it as FIFO creation. Generally, FIFO is first in, first out. Okay, uh, first in, first out. This way, one-way flow of data means suppose that we can take it as one pipe. We can drop it as three balls in that 1, 2, 3, 4 numbering. Then first ball will comes to as first out. Second ball comes to second out. Third ball comes to third out. Fourth ball is coming fourth. Okay, like that. People having the same name. So unrelated process can be shared the FIFO. Here mm, pipe and FIFOs are same, but in the pipes they have the some drawbacks. Uh, mm, mm, some drawbacks is there means they cannot communicate it as uh, two-way. They can communicate it as same ancestors in the pipe. Means suppose that two files will be created in the same directory, only they can communicate it in a pipe. But before they have the duplicate different type of directories will be there. They want to communicate it with the different type of directories. For here this before sometimes is called as names as pipes. Pipes can be used only between the related process when a common ancestors has created the pipe. This is the example within the same file directory they want to create it as whatever the same data in the pipes. Pipe can be used as to the duplicated and output stream in the series of shell commands. Okay, pipe is used to send data between client and server. FIFO is used to send data between client and server. Data is written to FIFO file and stored in a fixed size buffer and retrieved in a first in first out order. Okay, FIFO is generally first in first out order only. Okay, whether you want to fixed size means fixed size buffer is suppose that buffer is 10 KB is there. In the 10 KB whatever the data packets will come same as this data packets they can follow as serial process. That is the first in first out. Okay, this is the functions for the creation of FIFO. First one is hash include sys oblique oblique types dot h. Okay, next one hash include sys oblique stat dot h. Okay, next one, this is the function to creating as this is the header files. Next one, they want to creating as FIFO. Here the constant character as to path underscore name comma mode mode underscore t mode. Here they want to passing as two parameters. Okay, the mode argument just like a open. Okay, when a process opens a file, FIFO file, reading only, the kernel will be block the process until there is another process that opens the same file for writing. Okay, in this, in the sense, kernel will block the process until another process that will open the same file for writing. Means if you want to appending that same file in that way, uh, they want to wait it until who are the append to the who are the complete the up to the whatever the data whatever the data. If a process opens the FIFO for writing, be blocked until another process is FIFO for reading. Means another process try to reading in that means writing will be over, then only reading will be starts. This provides the method for process synchronization. Means in the sense, here writing until the another process will be reading process will comes to, then block will be released. Next one. Next one. If a process writes to FIFO that is full, then process will be blocked until another process read the data from the FIFO to make a room for new data in the FIFO. Generally, why? Because they are saying buffer will be have the buffer. Whatever the writing in the buffer will be going to data packets. They want to free the free the buffer. Means that is the whenever the reading process is started, automatically data will be transferred to another end. Okay, then buffer will be free. Okay, that's why they are every time they are saying as uh, writing is started, uh, uh, writing is blocked, then reading will be started. Okay, the process will be blocked until another process has read data from the FIFO to make room for new data in the FIFO. If a process attempt to read the data from FIFO is empty, then process will blocked until another process will data to the right. This is also another one more condition. If the read there is no empty in the FIFO, automatically they want to block it until another process will be write data into the FIFO. Okay, if a process does not decide to block by FIFO file, it can specify it as 0 o underscore non-block flag in the open call to the FIFO file. Okay, if you don't want to block that read at that time reading the writing the file and reading the file blocking. If two processes are to communicated via FIFO file, it is important that the writing process close its file descriptor when it is done, so then reader process can see the end of the file condition. Means nothing but here they want to passing as parallel processing reading and writing. Okay, uh, here we can discuss as FIFO file disk. Since the FIFO is actually a file on a disk, uh, we, it is not not that it is not that hard. We can have the call mknod node mknod node function with a proper arguments, that is creates as a FIFO, that is mknode my FIFO is the FIFO name s underscore FIFO. Okay, that is the creation starting of the FIFO. Here they want to given as uh, permissions comma 0. Here we can in the above example FIFO will be called as my FIFO. Okay, the second argument creation the mode which is tells us mk no to make a FIFO as underscore FIFO uh, insert FIFO part of or set access permissions to the file octal. This is the next argument pipe symbol. They want to processing as read and write permissions, which can also applicable set by the ring together macros from the sys obliques stat.h. The permission just like one we did using as change mode command. Finally, the okay change mode command. Next one comes to us. This is the example to creating as FIFO processor. First, I want to writing as FIFO. FIFO normally it is compiling in the C. You are writing the C program. Here they are defining as header file hash include std.h. Okay, hash include stdlib.h, hash include error number.h, hash include string.h, hash include fico control.h, hash include function control.h. That is next one hash include sys and oblique types.h, hash include sys oblique stat.h, hash include unistand.h. Here I am defining as one macro, FIFO macro, that is the name American made int void main. In that they want to take as uh, file descriptors characters int num fd. Here I am creating as one FIFO name comma as underscore fo. They can giving as permissions to the your FIFO. uh, okay, waiting for the reader fdp open file name comma. Okay, writing only got a writer type some stuff I'm giving as getting as message var f gets s comma size of s std dot in. If end of the file std dot in. Okay, then they can go through loop if number equals to write fdb comma fd comma file descriptor comma s comma string length of equals to -1. Then they can go through as error means in the stack is nothing that uh, sorry q is nothing but then automatically they want to display the error. If you have the some writing the words then only display as number. Next one reading the reading the data from the FIFO. They can same as this they want to create it as they want to writing as read only memory got the writer file descriptor comma s 300 up to 300 characters equals to process is read up to null characters they want to read it. They want to printing as num comma s while num greater than equals to 0. That is the FIFO creation reading writing the FIFO. Okay, here no delay FIFO will be unstartable. In this means whether we want to passing as parallelly read and write then we can use it as ftp open FIFO name comma 0 write only pipe of no delay. This is the only you can use to get a next one IPC between unrelated process using FIFO. Means here unrelated process using FIFO named pipes. Unrelated process means pipes meant interrelated process only. Pipes cannot be used for unrelated process communication. Interrelated process means that is the only one direct, within one direct only they can communicate it. Outside director they cannot communicate it. Okay, if you want to execute one processor from the one internal and another process from the another terminal, this is not possible within the pipes. Named pipes is meant for communication between two or more unrelated processes, can be also bidirectional communication. FIFO is called as named pipes. Uh, Unrelated pipes is called as pipes. Unnamed pipes is called as pipes. And the bidirectional communication, that is the client sending the message to the server receiving the message and send back to the another message to the client using the same named pipe. Okay, that is called as FIFO. This is the example of how they are communicating as two or more communications. These are the clients. Clients will be sending us within the pipe using the pipe symbol, listening the FIFO and converting text is the FIFO. FIFO is the raw text of FIFO. Next is here a client will be initiate the request listening the FIFO, and whatever the request will be sending to the server will read the request, and in that child will be writing on that convert that text will be reading the client, then client will be writing the raw text to FIFO and reading the child. This the process will be going there in the FIFO. Okay, difference between unnamed and named pipes. This is the named pipe, unnamed named pipes, and means this is the pipe and this is the FIFO. They exist as a directory entries in the file system, and therefore have the associate permissions and ownerships too. Okay, that is the one difference. Another one, they can be used by processes that are not related to each other. Okay, next they can created and deleted at the shell level or at the program level. These are differences between the unnamed and the named pipes. Okay, next one, f open sorry p open and p close library functions. In these sequences they can follow as generating a pipe, second one fork a child process, third one duplicating the file descriptor, fourth one is the executing new program in order of redirecting the input and output of the program to the parent. So common, the developer of the C library added the pair of functions popen and pclose streamline this processor. This is the hash include stdio.h file asterisk popen. They can pass as two type of arguments. One is the constant character command argument pointer type. Another one is the constant type will be passing as. Next one, int pclose file stream operator they want to pass as. In this popen function creates the pipe. Fork is creating as to execute the shell bin sh, which is system dependent, and pass the command to shell executed using -c flag to the shell, which tells it's expecting the command argument. Expecting the command argument. Popen expect to second argument is either R or writing. If R will be the process, invoking will be return the file pointer, read end of the pipe, and writing end will be attached to the standard output command. If W is the whether it is W, then process invoke returns the file pointer to the right end of the file, and read end will be attached to the standard input of a command. This output stream fully buffered. The streams created fopen must be closed as p close. P close will be waited for the process to be terminated and return to the exit status or -1 if wait for failed. Okay. Here the example sample example shape 3 will be they are taking as this is the example for this how they are actually what they are doing. This is the hash include stdio uni std means unidirection std output std lib.h string character purpose they want to take as limits.h. This is the command line argument. Okay, int n bytes file pointer and they want to read end of the file uh, file pointer f output writing and end of the file pointer character buffer of buffer buffering for buffer for transferring data. If argument is greater than 3 then f error they want to using as command 1 command 2 and they want to exit from this if loop. If input is f input is open then writing equals to null. Then printf standard error printf standard error printf sta- printf standard error failed to exit 4. Next one, if you next point is if output is open the file the argument to writing the equals to null then std error f open failed exit 1 while n bytes equals to read file number f input buffer pipe is buffering greater than 0. Okay, then we want to write in as the writing as printing as whatever the output in f print and f out f in and f out, that is okay, that is it the FIFO.